Can anyone confirm if I'm audible?
Yeah, sir, you're audible.
Oh, thank you. Okay, it's almost 6:05, so we'll start. My screen is visible, right? Okay. Okay, so again, welcome to the live session two of this course named Digital Electronic Circuits. Uh, I'll give my brief introduction again. So I'm Anand Singhal, PhD student from IIT Jodhpur, and I'll be covering the week three content today, which consists of minimization of Boolean expressions, costs, and again static errors and dynamic hazards, and what are their options to cover. So in the last week, we were left with some questions regarding the minimum number of NAND gates and NOR gates. So initially, I'll cover those questions and cover the concepts of those because it was left behind in the last week's lecture. So, and then I'll come up to these topics of minimization and this hazards. And whenever anyone have any query, they can post it on the chat box. So I told you specifically to come up with the solution of those questions beforehand. So is there anyone who has done the questions beforehand? I'll go to the slides. Yeah. So yeah, this was a question which I told you to cover. Can anyone confirm if they have done it? You can write on the chat box. Anyone? Am I not audible or you are not responding? Hello? Can anyone confirm if I'm audible? Please type it over the chat box if I'm audible. Okay. So if I'm audible, so I'm asking that is there anyone who has done these questions which I talked about in the last week's lecture, or do I need to solve them by myself? Okay, let's fine. I'll solve them by myself. Yeah, three NAND gates. So yeah, I'll cover the concept of these types of question if you receive any in the future also. So basically, so there are two types of implementation to do these types of question. One is and or implementation, and one is or and implementation. So this and or implementation means that we have a set of AND gates giving some output for certain inputs, and it is getting in some stage of OR gates in the second stage, something like that. Maybe we can take more gates. So it is and or implementation, and or and implementation will be when we have OR gates initially, which are going to a certain end of outputs. So this one is and or, and this one is or and implementation. So whenever you see a NAND minimum number of NAND gates asked in any competitive or in any exam, you should think beforehand that you have to go with and or implementation. Even in the if the question says that the expression is something which is not and or which is or and, you should first change it to and or and then try to proceed with the question. So in this question, what is written that we need to realize AB plus CD using NAND gates. So this slide, yeah. So it says we need to realize AB plus CD using NAND gates. So it says AB plus CD. So if I try to make the circuit diagram of it, so it is first AND of AB, AND of CD, and then it is getting odd. It is nothing but AB plus CD. Is it fine with all? Is there any doubt in the circuit?
No, sir.
It is quite basic, I guess. So this is nothing but and this is nothing but or. So we can call this as and or implementation. So I just told you that whenever you see and or implementation, you should go with NAND. Or if you have been given to make anything using NAND gates, so you should first convert the expression to an and or implementation, and then try to proceed with the question. And for or and, when you have been given NOR, so in this question already you have been given an and or implementation. So first you will just make the circuit. So I'll make it again. Yeah. This is right. So now you'll see the beauty of this. So now we need to realize this using NAND gates only. So if I use a NOT gate and a NOT gate again, if I'm using A, so what will be the output of this? It will be nothing but the same whatever the input has been given, because two NOT gates are nothing but a buffer circuit. So it is nothing but whatever input has been given is coming to the output. Is this clear that if I use two NOT gate, it will cancel the effect of each other? Please
Yes,
respond,
sir.
guys. You need to be interactive enough. Yes.
Yes, sir.
So now what I'll do is I'll use a NOT gate here and a NOT gate here. I hope this bubble, you know that bubble signifies NOT gate. So basically in this branch, I'm using two NOT gates, something like this. And one NOT gate here and one NOT gate here. So I hope you all are clear that this circuit is still the same. It is still AB plus CD only because I have just used two NOT gates in both the branches. Is it fine?
Yes, sir.
Yeah. So now you can see that this gate is already the NAND gate that we were looking for, and this gate is also the NAND gate we were looking for. We were just left with this gate, so I'll try to solve it. In black. Yeah. So it is something like this. Now let's suppose I give an output AB and we'll get something X, which will be nothing but A. It will get the output of A bar and this will get the output of B bar. So it will be nothing but A bar plus B bar. And if I try to solve a NAND gate, AB. So it will give an output of A dot B whole bar, which is nothing but A bar plus B bar. So you can see this NAND gate and this is also an AND gate. They both are equivalent, right? Did you get this? Anyone? Yes. So this is also an AND gate. So if I try to make a circuit, maybe here I can make. So if I make this is nothing but this only. So as given in the question, it was already AND or implementation. So this approach will always give you the minimum number of NAND gates required to solve the question. So if I use here A, B, C, D, and Y, so the output of this will come as AB plus CD. You can check by solving it using the circuit also. So the correct answer, wait, yeah. So the correct answer to this question was 3. So you require 3 number of NAND gates to solve this expression. Is there any doubt? I can give you 2 minutes. If you have any doubts, you can type in the chat box. Yeah, you can type in the chat box, whoever has raised the hand. Okay. So yeah, there will be one more question of the similar approach. I guess you all can try it. I'll give you 5 minutes at max. Yeah. So this is the question. Now you know the concept, so try to solve it by yourself. It is asking that what is the minimum number of NOR gates required to realize expression A plus B, which is ANDed with C plus D. I'll give you 5 minutes. Okay, I'm getting answer 3 NOR gates. 3 NOR gates. Okay, we'll see if they are correct. Everyone, please try to be interactive and attentive enough and solve simultaneously as I'm solving. No one else is getting any answer. I see three, four people have answered. Okay, and all of them are saying three Norwegians. Okay, so I'll try to solve it. So now, if I try to make the given expression, it is nothing but a plus b into c plus d. So it is nothing but a plus b c plus d. And it is getting ended. So if you try to solve it, it will give a plus b into c plus d. I hope this is clear. So if I try to do what I did in the last question using two NOT gates, will the circuit remain same? No, this will be easy. It will give nothing but a bar dot b bar. And if I try to make a NOR gate, it will give nothing but a plus b whole bar, which is nothing but a bar into b bar. We can see these both the gates are equivalent. So if I can make the circuit equivalent to this, it will be nothing but and it will give the output of a plus b into c plus d. Uh, is everyone agree? Please confirm if you understood this. Is there any doubt? If you understood, please respond. Okay. So yeah. So the correct answer to this question will be three only. All of you have those whosoever have solved it have given the correct answer. Now I'll try to make something else. Yeah. Now try this question. It is again dependent on the similar concept. So it is nothing but you need to make this A XOR B using NAND gates. And you need to tell the minimum number of NAND gates required. Okay, I have four. So I've got two answers. They're saying four NAND gates. Those whosoever have solved it, they can try this question. Uh, minimum. Maybe you can take it as a homework problem. Minimum number of two input NAND gates required to realize maybe. And I have specifically written two inputs. This is a homework problem for whosoever has solved the earlier problem. So yeah, those who served any, I'll try to make the circuit maybe on the next page. Yeah. Sorry. So yeah, this will be the output of that circuit. It will give you nothing but A XOR B. Is there any problem? Wait a second. I hope you get it. So the correct answer is 4 only. And this is the homework problem. This was left in the last lecture, so I've covered it this time. So now we can proceed with the some basics question, and then we'll try to go with the topics of hazards and total cost, etc. So you can also try to solve it simultaneously and tell the correct answer. This is a basic question. You just need to minimize a variable four variable boolean expression using whatever you want. This is the minimization. So I'll use kmap to solve this. You can use any method you want to. I'll give you 2 minutes and then I'll try to solve it by myself. Someone has responded B, so yeah, we will check if you are correct or not. Let me try to solve it. This will be even. So we'll write one variable is in 1, 2, 3, 7, 5, 8, 9, 11, 13, 15. Everyone is fine with this? The diagram that I have drawn? This is a basic K map. Okay, now first of all we'll try to make the octet if we can, then quad, then pair, and then a singlet if there is any. First we'll check this octet. So you can see there is one octet. I hope this is clear. And then we'll check if there is any quad possible. So you can see that this one is left. So we can make a quad like this, right? So for this, the solution will be nothing but D only. And for this quad, the solution will be B bar and then C bar is common. So the correct uh, minimization will be nothing but B bar, C bar plus D, which is yes, option B only. Zero is not minterm. Yeah, zero is given as a minterm. Here it is. Uh, Please specify your doubt, BR Santosh. What do you mean by zero is not a minterm? Okay. So yeah, this was just a basic question. There will be one or more question like that. You can solve them by yourself. Yeah, try to give the answer to this question as fast as you can. And we'll check in 2 minutes. Uh, R.A. Keshwani, please turn off your camera. Over there. Is given 4, 6, 7, 10, 11, 12, and then 15. Okay. So one chord possible will be this, and will be this. This one is also left, so one will be this. If I try to solve it, this will give nothing but B, and then here it is dy. This will give A, and
Yes. No.
Am I audible now?
Yes, sir.
Okay, I guess there is rejoining. Give me a moment. Till then, I'll try to solve the questions here only. I'm, I'm audible, right? Please, someone confirm if I'm audible.
Yes, sir.
Okay. So yeah, this is what we were doing. Yeah, this is one of the other basic questions, so you can try it. Till I'm trying to join from my other screen. You can try this one. Has anyone solved it? I'll give you a hint. It is just nothing but a POS expression given. So to make it a SOP, you can just open the brackets and try to solve them. It will be very easy then. KMF will be a very long approach to solve this question. I'll solve it simultaneously. Open this. I know. I hope you know that x into x is nothing but x. So this one will be x5. This will be x5 only. And this will be x5 z plus y plus y. No, x of x is nothing but x only. These both are same. X5 plus xy. This applies to this also. Okay, I'm writing something extra. Xyz plus xy plus yz. Okay, so this is xyz is coming two times. Okay, sorry. This is az. Hmm. So the final answer will be xy plus xyz plus xz, which is option C. I hope it is clear. Option B, you are saying. Option C is the correct answer. So please recheck and tell me if you are clear. Is everyone clear? Please respond in the chat box. I did not see any response. Is it like I'm not audible? Hello? Hello?
Yes, sir.
Okay. So you were saying maybe B is the answer. Okay, I'll check. Yeah. I'll redo it here. So I'm opening this xy plus xz and then multiplying it with x plus y plus z. So I'm multiplying these with this first. So it will give xy plus xy again plus xyz. And now this xz plus xyz plus xz. So xy are common, so this is xy. xyz is common, so this is xyz. And xz is common, so this is xz. So it is C only. Why B? Can anyone tell why they are saying B? I'm not getting it. Uh, who's saying Sai is also saying B and Santosh. Is it fine? Is it C only? Yeah, C is correct. No, we are opening it. I'm not taking anything common. I'm trying to convert this SOP, POS to SOP. I'm not minimizing the expression. And how can you take X, Y common from any term? I did not get it. Are you clear, Sai? Yeah. So we will try to solve the next question, which is, yeah. So this is something complicated. So this is a five variable K-map question, and this is even a US question. Okay, I'll do it by myself. Give me a minute. Okay, I was not audible. I solved this question now. I hope I'm audible. If I'm not, please type in the chat box. So this is a five variable K-map question, and we'll try to solve it using a four variable K-map. So for five variable, we know that we need 32 bits. So we'll try to solve it using, we're taking one of the variable as a bar and one of the variable as a. Sorry. So we'll make two four variable K-maps. This is for B. Uh, D, E, D, E. So for first we'll fill this. and for second we'll continue the same. It is still 50. Mhm, 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 51. It says uh and okay, it was min term, so please ignore these. It says 0, 1, 3, 6, 8, 9, 11, 13, 14, 16, 25. I don't care. 5, 7, 12, 15 is also don't care. 17, 23, 23. Okay. I hope it is clear. So from the first, we'll make this as a quad. This is a quad and this is a quad. And second, if you want to go all the zero, this is a quad, this is a quad, and for zero, this is a quad. Okay, for yeah. So for this solution will be this B and this is D. D1. Okay, here a octet is possible. That is why it was not giving the correct answer. Then we can make these. So yeah, for the first part it will be E bar and A. For first it will be A plus E bar, and rest is let's leave those and focus on heroes. Nothing but B bar plus C bar. Wait, I'll try to solve it. Acha, I have not. I missed something. 0, 1, 3, 4, 6, 8. 0, 1, 3, 4. Okay, a zero is missing here. 6, 8, 9, 11, 13, 14. 16, 7, 16, 19, 20, 21, 22, 24, 25. Okay. So yeah, because of that zero, this quad was missing. If I try to make this will be a plus d, right? Hmm. Oh, is this, which is a plus c bar. So this option is a plus c bar and this option is a plus e bar. Let's check for this also. I guess I missed something here. It will give a, this will give b plus c bar and this will give again, this will give e bar and this will give b. So this will give b plus e bar. These two are also there and one left is c plus d. So what is it, c plus d? Okay, yeah, this. Let me try with some different ink. This is giving c plus d. Yeah, so the correct answer to this question is option C. Sorry, it got a bit confusing because of the code that I missed. I hope you did get it. You can try to solve it by yourself also. You'll get the answer. So the correct answer is this option. Okay. Yeah. So there is one more concept named prime implicants. Prime implicants. In short, we call it as PI. So prime implicants are basically the all number of possible combinations, or basically possible ones given in the K map. And EPI, which is asked in this question, is nothing but uh, minimum or all number of pairs, quads, octet, which are necessary to realize the expression. So this is a given a K map. I'll make the boundaries. Yeah, and here it is as the total number of essential prime implicants (EPIs). So if I try to solve this and make quads out of it, wait. So one will be this, and now these three ones are left. So I don't have any other option just to cover like this. All are essential to realize expression. So that's why this is also required because this one does not have any other ones covering it. This one is also covered only one time, and this one is also covered only one time. So we need to maintain, and these all in this also there is one which is only covered one time. So four, all of them are required to realize expression. So there will be four EPI in this question. The correct answer to this question is four. Is it clear? Please respond. Okay. We can proceed to the next question. So again, it is uh, a basic K-map question of five variables, and this is time it is min-term question. So yeah, you can solve it. I'll give you 5 minutes. Then I'll solve it. Till then, I can make the diagram. Okay. Someone has answered B. We'll check. All of you, please try to solve the question. Okay, someone is getting D. We'll see if you're correct. Everyone else, please respond if you got any answer. Or if you are not even able to solve it, you can write in the chat box so that I can start. Okay, two. What do you mean by two? So option B you meant? Okay, we'll see now. Most of you are getting option B and one is getting option D. Okay, so yeah, I made the diagram for it. So it is very easy, I guess. In this, there is only one octet. And in this also, there is only one octet. So for A bar, it is nothing but D only. And for this thing A, it is only D. If I try to make D common, it will be nothing but A plus A bar. So A plus A bar is nothing but 1 and D into 1 will be D. The final answer is D only, which is option B. So Sai was getting D, I guess. Is it clear now, Sai? Okay. Again, this is a five variable question, so yeah, you can take maybe more than 5 minutes to solve this because it is a bit tricky. I'll wait for 5 minutes now. Please try to solve, everyone. And I want everyone to respond, not only two, three people. Please try to respond. Okay, no one of you is able to do it till now. Fine. I'll wait for 2 minutes more. It is only 2 minutes. Okay, one has solved and she's in option D. We'll check in 2 minutes. Okay. This is for A bar, this is for A. Sorry. This is B, C, D, B, C, D. The question says 0, 2, 8, 10, 11, 13, 16, 18, 24, 24, 24, 26, 29, 5, 6, 9, 14, then 21, 22, 30. Is it fine? So first we'll try to make the chords we can make using without using any don't cares. Then uh, this one is left and this one is left, right? We can make a pair for this and chord for this, and in this only this one is left. I hope it is clear. Please confirm it is clear the way I made. Please respond everyone. Okay, I'll try to write the expression. For this chord it will be, okay, let me write D bar E bar. For this chord it will be E bar and the second term is C bar. One order term will be C bar E bar, right? Hmm. For this it will be B C bar, and for this it will be C D bar E. Hmm. So we'll take those in which A is 0. So this will be A bar, B bar, C bar, and from the right this will be again the same, only this is left here. This will be nothing but C D bar E. It is there. One was C bar E bar, and what else was there? C bar E bar is coming in both the cases, so it will be A plus A bar into C bar E bar. So the final term to this will be C bar E bar, and again this is what A bar B bar C bar. Yeah, here it is. Here it is. Okay, yeah. So the correct answer to this question is option D. Is it fine? Do I need to repeat it? Please respond if I do need to repeat it. hope you get this thing mainly. For this corners, both had the same thing. So if I write for this, it will be a bar c bar e bar, and if I write for this, it will be a c bar e bar. And when I take common c bar e bar, so it will be a plus a bar, which is 1 only. That is why this is only c bar e bar. And same applies with these. When I'll write a bar c d bar e bar, a c d bar e, and when I take c d e bar common, it will be a plus a bar, which will give c d bar e. So one term will be this, one term will be this, and one term will be this. Oh, I got sorry. This, and one more is there, which is this. So the final answer is a bar b c bar plus c d e bar plus c bar e bar. This is option D. Is it clear? Please respond if you have any doubts. Anyone? Please respond. I'll wait for a minute. Please write even if it is clear. Okay. What about everyone else? Okay. No one else is responding. I'll proceed. Yeah, so this is one of the total cost question, which is one of the topic of this week. First of all, I'll try to cover basic concept that what is this total cost. Total cost is nothing but the cost of gates and the number of gates that we are using. And gate cost will be nothing but the literal cost and the total terms cost. So this is nothing but literal cost and this is terms. Literal, I know, I hope you know that literal are nothing but A, B, C. These all are literal. A is a literal, B is a literal, B bar is a literal. So to calculate gate cost, we'll calculate the number of literals in the expression. We'll add all the number of terms in the expression, total number of terms. So from this we'll get the gate cost, and after that, after getting the gate cost, we'll just add whatever number of gates that we have used to calculate the total cost, which is asked in this question. So here there are two functions, f1 and f2. First of all, we need to realize those functions. Let me use it. Okay, let me try to do it here. You also can do side by side. Let me write it here first. F1 is 0, 1, 10. What was that? Any picture. 0, 1, 10, 13, 14, 4, 5, 12. These I don't care. And for F2 it is 5, 8, 9, 10, 13. And don't care. Okay. I hope it is fine. Is there any doubt in this? Can anyone tell what are they getting? Anyone the expression for F1 and F2 if they have calculated? They can type in the chat box. I'll try to solve for F1 and maybe you can type for F2. So F1, this will be 1 pair and this will be 1. Will be nothing but B bar, C bar and A bar. C bar. This will be nothing but B, C bar, D bar, B, C bar, D, and this will be nothing but A, C, D bar. For F2, maybe you can try it. Is anyone has anyone been able to solve this, or do I need to write it? Anyone, please at least respond, even if you are not even able to solve this. This is important, so please respond. Okay, if you are not responding, then this is one thing. This one, and this will be one. Maybe this will give same BCYD. This will give AB bar C bar, and this will give ACD bar. Okay, this is all the same. So A B bar C bar plus AC dy plus BC by D. You can see this term is common and this term is also common. So first we'll try to calculate the gate cost. Gate cost is nothing but the literal plus number of terms. So I hope you know. Literals will be, since these are common, so we'll count them one only. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Literal will be 12 plus number of terms will be 1, 2, 3, and these are common, so we don't count them two times. So 1, 2, 3, and 4. The gate cost will be 16. Sorry, we need to count all the terms, not for literals. We don't need to count all the literals, but for terms we need to count each and every term since it is a different function. So these will be 6. Sorry, I'm repeating. So the gate cost will be 18, not 16. For number of terms, we need to count every term that we are getting, even if it is common. And now the total cost will be gate cost plus the number of gates. So you can see we require one, two. Let me change the color. This. So one gate, one, two, three, four, four OR gates, and for AND gate we require all of them as two. So two AND gates. So the gate cost will be nothing but 8 plus 4 OR gates and 2 AND gates. It will be 24. Is there any option 24? Is that? Yeah. The correct answer to this question is not C, it's B. Okay, someone has written. Let me recheck if you're getting this. B is equal plus A B. Okay. You are getting some other expression. I hope you have written it for F2. One of your term is A B bar C bar. A B bar. Okay, you have not used. I guess I got it. Maybe you have used this, not this. So if one is not repeating, then we should use don't care first. First, we don't look at the don't care and try to make every pair only using those ones which are present in the K map. Then, if the ones are getting repeating, then we should prioritize don't care to fill it up. So that is why I have taken this instead of this. Bhuvneshwari, you have written this.
Sir, hello,
So
sir.
yeah, is there any doubt? Wait.
Yes, sir. How we got this literal cost as 12? I didn't understand.
Okay, okay. Yeah, I'll tell you. So literal cost is 12 is, see, you see this is F1 and this is F2. So you can see here the number of terms which are common are, let me try to change the ink. So this term is common with this term and this term is common with this term. So we'll count it only once. Is it fine till now?
Yes, sir.
Or, so the, if I write the terms as like here, one term is A B bar C bar, which is this. Is it A bar? It is A bar B bar C bar. One term will be B C bar D bar. One term will be A C D bar, and these two are repeated in the second time, so we'll only write the term which is not repeated. A B bar C. Is it fine till now?
Yes, sir.
So now we'll count the number of literals since the terms are not uh, repeating. So we'll count each and every literal now. One, two, three. So in every term there are three literals and there are four terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is how got 12.
Okay, sir. Understood.
Uh, is there any? Did
Yes,
you
sir.
get it? Okay. One more doubt is how did we get two AND gates? So yeah, for every two or okay, I'll tell you two AND gates. To solve every literal, we require a AND combination of two gates. So I have specifically taken it for two input NAND gates. To solve every term, we need two AND gates, and all of the terms are getting odd by using four OR gates. That is why two AND gates and four OR gates. Four OR is clearly visible to you, and AND is between these terms. I hope it is fine. We can solve some more question. It will clarify more. So yeah, this is again a question in which we need to calculate the gate input cost without counting NOT gates and with counting NOT gates. So for that, first we need to minimize this expression. So anyone please try to do it as fast as you can and let me know the expression that you are getting. I'll also do side by side, but try to give me by yourself. This is yeah. Please be attentive. This is a POS form. So 0, 1, 7, 8. Anyone? I'll write it. Oh, there's no other option than to make these. Oh, one of it only. Where B was C bar. Oh, sorry. It was POS, not SOP. So one of it only be 8 plus. Wait. Option A you are saying. Okay, can you tell me the final expression that you are getting? A by B plus C. Yeah. Mhm. Is A plus C plus D. Yeah. So this is the final expression. I hope this is what you are getting. Hmm. So what we need to calculate the gate cost, which is nothing but the literal plus number of terms. So we are not counting any NOT gate first. So this is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9 literals plus 3 terms. Is it fine? Please respond if it is fine. Yeah, and then if we calculate the gate cost with NOT gates, it will be nothing but whatever the number of NOT gates, will just add them. So there will be 1, 2 NOT gates. Literal plus 1 plus NOT gates. 9 plus 3 plus 2, which will be 14. So, okay, 15 is option. Maybe I've written something wrong. This is A plus C plus D. This is fine. This is A plus B plus C. This is fine. And this is B bar plus C bar plus O. Yeah, this is also a bar. So this is 3. So 12 and 15, which is option A, is the answer to this question. Hmm. I hope it is clear. Please respond. We are running out of time. We need to cover a few more questions. Try to respond a bit fast. Okay. Okay. Maybe I'll try to give you one question. I'll give you a random question maybe. Let's suppose it is given AB by C plus AB by D plus ACF plus ADF. So can you tell me the gate cost with and without NOT gates? Gate cost will be literal cost plus number of terms plus यहाँ पे 0 because there is no NOT gate, and for NOT gates it will be, can you tell this number? You need to calculate the gate cost with and without NOT gates, and this is the expression given. Okay, someone has written 16 is the answer. 16, 17. Everyone else, please respond. Okay, so the literal cost will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for both the cases. Number of terms will be 4 for both the cases. And for NOT gate, there is only B bar present in the circuit, so one extra term will be there. So the correct answer is 16, 17 only. Uh, it will not be 18, love kush. You have written 18. So there is only B bar in the circuit, so we don't need to repeat NOT gate for every B bar. That is why we only need to add one, not two. I hope it is clear. Okay, so let's move towards hazards. So I'll tell you the concept of it first. So there are three types of hazard that we face in the circuits. One is static, one is static zero hazard, one is static one hazard, and one is dynamic. There's some problem with the pen. I'll write a bit slower. So whenever a circuit is encountering an expression like x bar, it can give for any combination of logic. If a circuit is encountering this type of expression, then it will give a static zero hazard. And for any combination, if a circuit is encountering, oh, wait, I hope green has gone, x plus x bar, then it is a static one error. And for dynamic, it is x bar plus x. So yeah, these are the basic things that you need to remember for hazards. For static 0, it is x bar. For static 1, it is x plus x bar. And for dynamic, it is x bar plus x. So if you know this much, it is quite easier. Uh, so it is given the question f is nothing but x plus z and y plus z bar. Can anyone tell me for what values of x and y we can get? Let's suppose I'll give you a hint. We can get z bar. So for what values of x and y we can get that z bar? Anyone? Okay, I'll frame a easier question. If we take x, y both as 0, then what will be the f? Please respond. Yeah, 0. So yeah. So you can say if we take x and y as 0, so we'll get z bar, which will be 0. So if we, for any combination of variable, if we are getting this type of variation in the circuit, this type of expression in the circuit, then we will face the static 0 hazard. And if you're getting this type of expression, then we will face static 1 hazard. So f is facing static 0 hazard, and there is one more term in the question, which is yz plus z bar. Sorry, yz plus xz bar. Can anyone tell for what combination of x and y we can get expression maybe z plus z bar?
Static one.
Okay, someone is. Can you repeat?
Static one.
Yeah. So if we take x y as 1, then we'll get f as z plus z bar, and it will always be 1. Sorry, it is z g. So for the g part, we'll be getting static 1 error, static 1 hazard. So the correct answer to this question will be option B. Is it clear?
Yes, sir.
Okay. So now try to solve this. So the expression is a c bar d bar b c bar d bar. Try with any combination and see if you're getting any type of hazard in this. So let's suppose if I take a as 0, b as 0, this will give c bar d bar plus c bar d bar, then cd plus this will be 0. So there is no error, c bar d bar is fine. So if I take maybe as 1, so it was 0. Sorry. So there will be only left with cd. If we take even as 1, so we'll be left with c bar d bar. There is no error for a and b. You can check the same for c and d also. If we take both of them as 0, so it will be a plus b. Mhm. And if we take both of them as 1, then it will be a bar plus b. Again, there is no common term. Are you getting what I'm trying to do? For any combination of the circuit, we should not get an expression like x bar, x plus x bar, and x bar plus x. So x bar is not possible in this because it is something like POS form. The x bar will never come. So this is not a possibility. For static one hazard, we should get x plus x bar. So c plus c bar is also not a possibility because if we take a as 1, so this will get 0. And again the same with d and d bar. Uh, and in this also, if we take b as 1, then this will, okay, let's try this. B C D bar plus B C D will get, and it's the hmm, okay, this is D bar. So if we try to take B as 1 and D as 1 to get C plus C bar, then this will cancel out the one effect. So there is no possibility. This was D bar. So there is no static one hazard also. I hope you are getting it. And there is no dynamic hazard. You can check. You will never get try any combination of circuit that you want to, any 0 1. You will never get this type of expression. So this particular question has no hazard. You can even check after the session also. If you are getting any, you can tell me in the next lecture. I'll move forward. Yeah, try to do this. This is a simpler question, so it will help. Tell me what type of error this circuit has. Okay. Anyone? Okay, someone is saying A, static 0. Okay, we'll check. Anyone else?
Static 1 hazard.
Sorry. Wait. Can you please repeat?
Static 1 hazard. Z plus Z bar. X
Static
is
one.
equal to 1, Y is equal to 1.
Okay, static one. Yeah, I'll check then. So from the expression we are getting xz bar plus yz. Yeah, for a value of x equals to y equals to 1, we'll get z plus z bar, which is static 1. So yeah, static 1 is the right answer. I hope Bhuvneshwar it is clear now because earlier you were saying it is static 0. Is it clear? Shall I proceed?
Yes, sir.
Okay. Yeah, try this question. Mm, This is a plus c bar, b plus c, and then plus c. Let me try to solve. So for limit of cc means I hope it is clear. If I take a as 0, so this will be gone. B as 1, so this whole term will be 1. And D as 1, so it will give C plus C bar. So we can have a static 1 error also. And we get A and B both are 0, so it is directly given C bar. And for the dynamic error, we can see here if we take A as 0, B as 0, and D as 1. So for A, B is 0, it will be C bar, and for D as 1, it will be plus C. So dynamic error is also present. So the correct answer to this question is option D. Is it clear? Please respond.
Yes, sir.
Okay. Oh, I was on mute. Sorry. So this is okay. This is a theoretical concept only. So I'll tell you the max minimum possible of EPIs in any number of in any certain expression will be zero, and the maximum number of EPIs will be always 2 to the power n minus 1. So this is just a theoretical sum. You can remember this. Option B is the answer to this. On the basis of this, you can try to solve a simple question, which is this. Yeah. So it is asking for n equals to 6. What will be the minimum and maximum API? Can you tell me fast? Okay. Anyone? Hmm. So minimum will always be 0 and maximum will be 2 to the power 6 minus 1, which is 2 to the power 5 and 32. So option B is the correct answer to this. So I hope first of all hazard and total cost is clear to you. Fine. So this was the main motive of this lecture. So if you have any doubts right now, you can ask. Otherwise, we'll close the session. Shall we close?
Yes, sir.
Okay then. We'll meet next week, same time.
Thank you, sir.
Thank you.